Okay, says it's being recorded. So, welcome. I'm Stephanie, of course, your professor. Um, this is your first live. I'm thinking this is probably going to be the same time that we'll do every week. We'll see. I haven't taken a look at the survey to see if times have changed based off of new responses. But I'm planning on keeping it at this time every week unless the survey says otherwise. So welcome. You are not required to have your webcam on. You're not required to have to turn on your microphone. The bottom right corner, there's a purple button. If you click that, that will open up options, and that's where you can find the chat feature if you want to use chat. If you have questions, you can type them in the chat, or you can raise your hand if you'd rather ask it with your microphone. There's a raise hand button in the middle of the screen at the bottom. So this is recorded. I'm going to email it out tomorrow. So I figured what I would start with is some information just about the course and what you need to do. All of this is already in the course, but just a refresher because there's so much information that you guys are learning that you may have missed some of this. So I'm going to go over that briefly, and then I'm going to go into a lesson on simplifying fractions. So I'm going to get back to my screen share. Hopefully soon it'll pop up. There, okay. So let's, if I can get my thing to move. There we go. Okay. So every week, this is what you have to do. You have your discussion. There are 4 mini assignments. I call them mini because they're 5 questions only. These are graded. And then you have to turn in a Connect Math screenshot. So there is a tutorial of how to do this listed on the Dropbox item or the description of this in Blackboard. You want to go to your Connect Math gradebook and take a screenshot so we can see the 4 scores that you got on those mini assignments. Because if you've looked at the gradebook, those scores don't transfer into the gradebook. So this is how we get the scores into the gradebook, is you have to take a screenshot of it, and then your score entered for the screenshot will be the average of the 4 scores. So that is required. There are optional assignments, and the videos that are linked in Connect Math are also optional. They're recommended, but they don't count for your grade. That's why they are a different color than the graded stuff. So the blue stuff is not part of your grade. The green, orange, and red are part of your grade. So if you want to kind of look at it color-wise, that's how that works. But the optional assignments are there to help you study for the quizzes and exams. Every week you're having a quiz or an exam, and then you have a Dropbox associated with that where you submit your work from when you take the quiz or exam. So the way that Connect Math works is that it grades it right or wrong. There's no partial credit, and let's say you're doing an order of operations problem and you make a mistake, but the rest of your work is correct. You just have 1 error. It's not fair to give you 0 points on that when you have correct work. So we're able to give those points partial credit for correct work when you turn in your Dropbox. And so when you do the quizzes, and this is not required for the homework, but just for the quizzes, you're going to want to do your work on a separate sheet of paper, and then you can take a picture of it with your phone and then upload it to the Dropbox, and then we look at your work, and then we award partial credit based off of that. You don't need to do this for the assignments because you have unlimited attempts on the assignments, so you can just keep doing it until you get it correct. The quizzes and exams only have 1 attempt, so this is how you can get points for correct work even if you didn't get the final answer right. So as far as how these affect your grade, the quiz drop boxes and your exams are worth the largest portion of your grade. So it's really important that you spend your time studying because these do make the biggest difference in your grade. The extra credit has already been applied for those who got stuff worked in by Sunday night. There were Connect Math issues, so some people weren't able to do that. So I'm going to go in tomorrow, and any work that's submitted by tonight is also going to get partial credit, just because we had issues where somehow we lost our license to Connect Math. Something got turned off on the back end on the publisher's end, but that has been resolved. So some specific details, and I am going to email out this PowerPoint tomorrow, so you don't have to rush to kind of write all this down. But discussions, should have at least 75 words for your main answer to the prompt. You need to have at least 2 replies, and good replies are at least 40 words. And if I've already graded and you only did like the main post, it's the end of the week, and you didn't do replies, you don't get to go back and do your replies after the fact, after I took off points for it. Because the whole point of replying is to do it during the week of the discussion. Connect Math assignments, I already mentioned everything about that. I already talked about the screenshots. The quizzes and exams, those are timed. And as soon as that time ends up, it will auto-submit on you. And if you're doing it close to the due date, it will auto-submit as soon as it hits the due date. So you want to be aware of that. So you don't want to start it like 5 minutes before it's due, because it will submit after that 5 minutes and you don't get your full time. Now the quizzes and exams are open book, open notes, but that doesn't mean that they're going to be easy. Generally what that means is that you can use it as reference, but you still need to know what you're doing. The whole point of the quizzes and exams are to see if you can apply what you have learned. And so having organized notes is helpful, but you do still need to study and practice in order to learn the material. And then I already talked about the Dropbox where you have to upload your work. I talked about the partial credit. This also allows us to give you points. So if the answer is 6 and you wrote 6/1, we can give you credit for that if it was marked incorrect. So it allows us to also make some adjustments to your grade if like you have the right answer, you just didn't put it in the correct format they wanted. And no quiz corrections are allowed. So you don't want to go back and fix your answers after the fact, because that's defeats the purpose of the quiz. The quiz is to see what you know at the time that you take it, not can you look at the answers afterwards and fix it. So there's a lot of resources. I'm sure you've already seen all this in the class, but you've got your textbook. I do have 2 recommended online calculators that are linked here. So when I email this out tomorrow, you'll be able to open it up and just like literally click these links to go to these calculators. We'll be doing graphing the last 2 weeks of the class. The rest of the week or rest of the time, the scientific calculator would be very helpful. You've got tutor.com. You've got the supplemental materials area. In week 1, there's a suggested schedule for time management. And I've got a whole bunch of YouTube videos that are linked in the weekly content. So if the videos in Connect Math are not enough for you, you can look in Blackboard. There's tons of videos there. That's where I'm going to be storing the live sessions as well. So lots of things are available for you as far as resources. And then best way to contact me, the quickest way is through Remind. There is a thing in the classroom to sign up for that. I send out announcements, tips. If there's issues with Connect Math, I'll send that out through there. If you reply to anything, it only goes to me, so you don't have to worry about it. It's not like a group chat. It's nice because you can access it pretty much with a phone. You can even access it on a computer. You can have it emailed to you. And sometimes I don't get notifications on it for whatever reason, but for the most part, I'm pretty quick replying to that. The other quick way to contact me is Google Hangouts. If you sent me a chat through there, that also goes to my phone. So those are the 2 quickest ways to get a hold of me. Then there's also email and phone. So email, I pretty much check during my working hours, like 9 to 5, Monday through Friday. I don't check my email on Saturdays, and then Sundays I check during my office hours. So if it's the weekend and you have a big issue or that needs to be fixed right away, don't do email because you're not going to get a hold of me immediately. You won't hear from me until Sunday. And then phone, this is only during office hours because I have to, the phone number is literally my computer, not my cell phone. So we use voice over IP. So it's literally my computer. So it's only when I'm at my work computer that you can get a hold of me, and that's during my office hours. So if I don't answer and it's my office hours, I might be in a meeting or I might have just stepped away. So always make sure that you leave a message, make sure you have your name, what course you're in, your phone number, so that way I can call you back. So that's important information that's already in the classroom in various places, but now you'll get a copy of this so you can review it elsewhere. And now let's actually learn some math. So, all right, so actually before I get into this, are there any questions before I start doing a lesson? Okay, so then let's do our lesson, simplifying fractions. So I know a lot of people hate fractions, and I used to dislike fractions too, but I have found that they're actually, once you understand how they work, they're not so bad to work with, and they're easier to work with than decimals. I'm a lot better at doing math with fractions than I am with decimals. I'm more likely to make a mistake if I have to do any multiplication or adding with decimals. Dividing decimals is a pain in the butt. So fractions are not bad once you understand how they work, and that needs to start with simplifying fractions, because everything you do in this class, if you have any answers that are fractions, you always have to simplify them and reduce them. And this goes to, I mentioned 6 and 6 over 1. 6 over 1 is not fully simplified. 6 is the simplified form. So we always put things as simple as possible. And so this is one of the things that you need to know how to do. So let's just start with some definitions, such as a fraction. So a fraction is a specific number where we have something over something else, and we have this horizontal bar, and that basically means division. So it's basically the top number divided by the bottom number. And if you were to put a fraction as division in your calculator, you would get a decimal. It would actually divide the number. We are not allowed to have 0 in the denominator of a fraction because we can't divide by 0. The top of the fraction is called the numerator. The bottom is called the denominator. You can think of denominator as down, and that can help you remember that that's the one on the bottom. I usually just say top and bottom because those are shorter to say than numerator and denominator. A proper fraction is where your numerator is less than the denominator. Basically, the top is smaller than the bottom. These are numbers that are between 0 and 1. Improper fractions are where the top is bigger than the bottom, and these are numbers that are greater than 1. Now, you may be used to taking fractions and turning them into mixed numbers. Generally, once you start working in algebra, and then if you have to go into higher levels of math, we don't work with mixed numbers because they're harder to do math with. They're harder to multiply, they're harder to divide. So we leave things as improper fractions. You do not have to turn anything into a mixed number unless it specifies. So don't worry if you have an improper fraction. That's completely valid, and it's actually preferred. Prime factorization. So I have a whole video devoted just to prime factorization. So I'm not going to go into too much detail on the process here. There's a video you can watch on it, but it is a process like addition. It's like an action that you do where you're writing a number as a product of primes. So product means multiplication. So that means we're multiplying primes, and prime numbers are numbers that are only divisible by themselves in 1. So if you can divide a number into it, it's not a prime number. So prime factorization is taking a number and rewriting it as a series of prime numbers multiplied together. And this is important because this is one technique for simplifying fractions. Another vocabulary you need a vocabulary word you need to know is factor. So that comes in the word factorization, and factors are numbers that divide into another one, or they're also called divisors. So 2 is a factor of 6 because 2 divides into 6. So when we do prime factorization, we're looking for prime numbers that divide into a larger number. That's what this is. And so we use this for reducing fractions. It's also used later in the class, or like later, just this week also, for finding common denominators, but it's used later in the class for factoring out the greatest common factor. So it's a very helpful technique that's used a lot during algebra. So I actually just listened to a podcast today that I meant to email out to people that actually talked about factorization. And I'm like, oh, hey, we're actually kind of talking about that today. So I didn't email that out yet, but I'm totally going to do that. It was really interesting. It was actually about a mathematician who thought she wasn't good at math, and then it started making sense, sort of like my journey, where it didn't make sense immediately. So I listened to it, I'm like, she sounds like me. So really good podcast. I'm going to email that out, but it actually talks a bit about factorization. Okay, so here's what you guys are here for, simplifying fractions. So there's 2 terms that we use for this, simplify or reduce. They basically mean the same thing. They basically, what they mean is you're taking a fraction and you're trying to turn the number smaller. Simplifying is all about making things smaller. You're turning something that may have lots of things into fewer things, or in terms of fraction, you've got these big numbers on a fraction, you want to make them smaller. And that's why it's called reducing as well, because you're making the numbers smaller. And this is based off of 3 rules. The fact that if we divide things by 1, it doesn't change. If we multiply things by 1, it doesn't change. And if you divide a number by itself, like 2 divided by 2, it's equal to 1. So these are like the 3 principles that we use for simplifying fractions. And this is part of the fundamental principle of fractions. So basically you have some fraction and you turn that fraction, like if I had, I don't know, whoops, I'm just going to make up some numbers here. Like if you have 6 over 12. The principle of fractions says you rewrite this so that you're multiplying these numbers by the same thing. So this could be like 6 times 1 and 6 times 2. Or actually, if I want to line it up the way that they did it, 1 times 6 and 2 times 6. So you're just splitting it up into 2 numbers multiplied by each other, but they still have the same number in there, like they both have 6 in there. So that's considered a common factor. And the way fractions work is that you can rewrite this as 2 separate fractions. Instead, you can kind of split them apart. And then 6 over 6, that uses this rule right here. Anything divided by itself is equal to 1. So that's really 1/2 times 1. And anything multiplied by 1 is equal to itself. So it's 1/2. This is what the fundamental principle of fractions is saying. This is not the technique that we generally use. We don't normally go through rewriting it this way, but this is what the principle of fractions says, is that we're just taking numbers, splitting them up in ways that allow us to cancel things out so that it gets smaller. So if you are anything like me, you like to have steps to follow. So there are 2 different methods for simplifying fractions, and so I've got both methods here. There's the repeated division method, where you just continually divide you have a fraction and you divide the top and the bottom by the same number, and you do it over and over again until you can't do that anymore. Then there's the prime factorization method, where you do prime factorization and then you cancel everything out that's uncommon on the top and the bottom, and whatever's left over is your answer. So I actually use both methods depending on the situation. So it is useful to know both methods. If I'm dealing with fractions with really large numbers, I will do the prime factorization method. If they're smaller numbers, I will do the repeated division, because it's like I can look at it and be like, oh, I can divide both of these by 2, and I can just do that and then look at smaller numbers. So I use both methods kind of depending on the situation. Both methods work all the time, so it's up to you which one you prefer. But I'm going to show both methods because they both work, and it depends on how your brain works, basically, on which one you prefer. So we're going to start with our first one, 42 over 48, and we want to reduce this. So the repeated division method basically is saying, what numbers can I divide into both 42 and 48? So you have to know your multiplication and division tables really well for this, basically. So if you're not really good with your multiplication division tables, definitely get flashcards, because it makes things go faster. Like, I look at this and I'm like, well, I know 42 is 6 times 7. And 6 also goes into 48. So I can divide both of these numbers by 6. But you can also look at it and say, well, they're both even numbers, so I can divide them both by 2. So let's say you're just looking at it and you're like, they're both even, I'm going to divide them by 2. So you start with your number, your fraction, 42 over 48, and we divide the top and the bottom by 2, if that's the number that you see in common. And so you have to actually write that out, and you have to write out that you are dividing them both by 2. If you write only, let's see let me do this in another color. If you wrote it this, that is incorrect, because that is saying that you are only dividing the bottom number by 2 and not the top number. We're dividing both, so you can't just write divided by 2. That means something different, because that is actually dividing by the number 2 over 1, and it's totally different. So you can't write that. You have to write down that you're doing it on the top and the bottom in order for it to be mathematically correct. And then you divide going across. So 42 divided by 2, if you don't know that, you can use your calculator, and that's 21. 48 divided by 2 is 24. So then you look at what you have here and you're like, okay, now what can I divide out? 21 is, I can, 3 goes into that, 7 goes into that, 3 goes into 24, so you can say, oh, I can divide both of these numbers by 3. So then you write that in, that you're going to divide them both by 3. 21 divided by 3 is 7. 24 divided by 3 is 8. And then you say, okay, do 7 and 8 have any numbers in common? 7's a prime number, so nothing divides into 7. So we can't reduce this further. And then that's your final answer. So this is called repeated division, because you're continually dividing numbers out until you can't anymore. If I had divided this by 6, it would have been a one-step process, because I would have gotten straight to 7 over 8. So you could do this in one step and say, oh, I can divide it by 6. Or you can say, well, I can divide it by 2 and then divide it by 3, which is the same thing as dividing by 6, because 2 times 3 is 6. So this is the repeated division method. And I use this method if it's pretty easy, if I know my times tables and I can do it in one step. Like if I looked at this and was like, oh, I can divide them both by 6, I'll do the repeated division method because it doesn't take too long. The other method we have is the prime factorization method. And so when I do prime factorization, I make what I call factor trees. So I take, let's take our top number, 42, and I say, okay, what numbers multiply to 42? 6 times 7. So you need to know your multiplication tables pretty well. 7 is a prime number, so you circle it. And then 6 you can split up as 2 times 3, and 2 and 3 are prime numbers. And then once everything's circled, you can't split it up any further, you're done. And then you go to the next one, 48, which I know is 6 times 8. 6 is 2 times 3. 8 is 4 times 2. And then 4 is 2 times 2. So you're kind of breaking these up as far as they can go. And once you've done that, then you rewrite your fraction. So we've got 42 over 48. And 42 is equal to, and you can take each of these circled numbers and multiply them. And notice I'm using a dot for multiplication. Always use a dot once you get to algebra. Don't use the X, because we're going to be using an X as a letter. So use a dot. And then 48, I've got 2 times 3 times 2 times 2 times 2. So I'm just writing down all of my circled numbers when I kind of split it up. And then what you do is you cancel something on top with something on the bottom. So I can cancel out 2's, I can cancel out 3's, and then I don't have anything more to cancel out. So there's a 7 on top, but there's nothing on the bottom. So then you just multiply your numbers together. On top, all I'm left with is 7. On the bottom, I have 2 times 2, which is 4, times 2, which is 8. And you get the same answer that we did with the repeated division method. So this was an alternate method. This is using prime factorization, where you're just kind of splitting your numbers up as far as they can go, and then you cancel out what is in common, and then that gives you your simplified form. So I'm actually going to start a poll because I am curious which method you prefer so far based off of this example. So give me a moment while I type these choices in. Okay, so it should show up on your screen. So you can choose which one you like. And basically, based off of which one you like, that's the method that I'm going to do. So, because that way, you know, if that's the one that makes sense to you, that's the one I'm going to follow. But there are some where I'm going to specifically do prime factorization, if everybody likes repeated division, or there might be some where I do repeated. So if I show the responses there, so it looks like there's 2 people who haven't voted, but I think one of those is actually me. I think it counts me. The clear winner here is repeated division, so that is what we're going to do, except in some of the cases with the larger numbers where I'll do it with the prime factorization. So that is what I will do going forward. And you can always do prime factorization on your own and double check that you get the same answers. Okay. So here are 2 different fractions. One is a proper fraction on the left, the one on the right is an improper fraction. We want to simplify these, which means reduce. These are the same things. I am interchanging the vocabulary so you get used to knowing that these are basically meaning the same thing. So first one on the left, we have 3 over 15. And this one's pretty easy to do in one step because the numbers are really small, which is why with small numbers, I usually just use the division method because I can do it in one step. I can divide both of these numbers by 3. So I'm going to make sure to write that in. You want to make sure that you write it on both the top and the bottom. And what's nice about this method is that you can see the math that you're doing. So if you make a mistake, you can check your work pretty easily. 3 divided by 3 is 1. 15 divided by 3 is 5. And then I can't make anything smaller than 1, so that is the simplified form, 1 over 5. Now let's look at 16 over 6. So you guys are welcome to put this into the chat. What number can I divide out of both 16 and 6? So what number am I going to divide out? So you can type. Okay, we've got 2 people that both say 2. And if you don't feel comfortable chatting to everyone, if you hit the little arrow, you can also send chats only to me. So if you don't want everybody to see it, that's totally fine. 2. 2 or 3. So I look at this and I would say 2 because the numbers are even. So any number that is an even number, I just automatically divide by 2, and then I look from there to see if there's something else that I can divide out. So let's do these by 2. That's like the easiest thing. And then we can say, okay, is there anything else that I can divide? So 16 divided by 2 is 8. 6 divided by 2 is 3. So now we have 8 over 3. And if we want to reduce this further, we're looking for a number that we need to divide out of both of them. One common thing that I see a lot of people do is they divide the top and the bottom by different numbers. So they might say, oh, I can divide 8 by 2 and 3 by 3. You can't do that. You have to divide them by the same number. And that's why it's so helpful to write down what number you're dividing by so you can make sure that you're writing the same number. And if you write it down and then you realize, oh, this actually gives me a decimal when I divide it, that means you need to pick a different number. So 8 and 3 don't have any numbers in common. So 3 is prime. You can only divide it by 3. And 3 doesn't go into 8. So this would be considered our simplified form. And we don't bother making it a mixed number or anything like that. We're going to leave it as an improper fraction. It's just now it's a smaller fraction. Are there any questions so far?
No.
All right. Hopefully this is making you not as afraid of fractions. If you look at it, you're like, this isn't too bad. All right, so now we're throwing in some bigger numbers here. 48 over 64 and 32 over 48. And I got a question. Would memorizing prime numbers be helpful? Yes. Memorizing prime numbers and knowing your times tables are very helpful because that way you don't waste your time trying to look for a number that divides into it when there is no number that divides into it. If you know your times tables basically through the tens, then you basically know the prime numbers through 100, because if it's not in your times table, then it's generally a prime number. There's also something called the sieve of Eratosthenes. So Eratosthenes was this Greek dude, and he came up with this thing called the sieve, where if you write your numbers, and so this is kind of stupid writing these out right now, but you'll get the idea. So you just keep going, and then what he does is, so first off, he doesn't count 1, because 1 is not a prime number because it's only divided by 1. 2 is a prime number, and then you cross out every number that's a multiple of 2. And so you just go through, cross off all the multiples of 2, and you would keep going. Then 3 is the next prime, and then you cross off multiples of 3 if they haven't already been crossed off. So all of the multiples of 3 are already crossed off. Then you move to the next one, and you have 5. You start crossing off multiples of 5. Oh, actually, I missed a multiple of 3, 15. So you keep going, and 3. I don't know how I missed that. That's a multiple of 3. So you cross off the multiples, and then you're left with the prime numbers here. So 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13. And these are all numbers that if you tried to think of something, if you try to think, is there a number that divides into it, and you know your times tables, there's nothing that divides into those. So knowing your times tables helps you know those prime numbers for the first numbers 1 through 100. Another question was, can you reduce the last problem? So let's go back. Can you reduce that further? And the answer is no. So while I could divide 8 by 4, I cannot divide 3 by 4. So if I tried to divide these both, so if I'm like, oh, well, 4 can go into 8, I have to also do it in the bottom. 8 divided by 4 is 2, but then 3 divided by 4 gives me a decimal. And as soon as you get a decimal, that's bad. We don't want to have decimals in our fractions. Generally, never leave a decimal in a fraction. We want to have whole numbers in our fractions. So if you get to that point where if you divide it and you got like a decimal when you try to do it, then you can't actually reduce it further and you're left with where you were at. So 8 over 3 is reduced because we can't divide a number out of both 8 and 3. It has to be able to go into both of these. So that answers that. Talked about your prime numbers. And so let's start reducing. Let's look at these fractions that we have. So the first one we have is 48 over 64. And so these are larger numbers, and if we use the division, you need to say, what number can I divide into both 48 and 64? It has to go into both. It doesn't have to be the largest number, it just needs to be able to go into both of them. So someone wants to type in the chat, tell me what number can we divide into both of these numbers? Okay, 8. 8 does go into both of these numbers, so let's start with that. So I'm going to write this down. We're going to divide them both by 8. So 48 divided by 8 is 6. 64 divided by 8 is 8. So now we have the numbers 6 and 8, and then we need to ask ourselves, is there a number that we can divide into both of these? Is there a number that divides into 6 and to 8? And if so, what is that number? So these are not prime numbers because they're not on my list of prime numbers. And so we look for yes and 2. We can divide 2 into both of those. So I'm going to write this down. And we're going to divide them both by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. And then 3 and 4 don't have any numbers in common. We can make 4 get smaller, but not by the same number that we can go into 3. 3 is prime. So once basically one of the numbers is prime, you're generally at your simplified form. So that's reducing 48 over 64, and that is the same thing as 3 over 4. So let's look at 32 over 48. So Same thing. You're just saying, what number can I divide into both of these numbers? So anybody can pop into the chat and tell me something that I can divide out. Okay, so we've got first number, 8. And if you know your times, yes, 8 goes into both of these. So once again, we will divide these by 8. But if I wanted to, I could divide them by 4. I could divide them by 2. I don't have to do 8. Christy says that we could divide it by 16, and that's correct. 16 does go into, pretty sure 16 goes into these. I'm not good with my multiplications of 16, so I would do 8 because, if you know your times tables up through 10, it's a lot easier than knowing your times tables up to like 16. But let's see, 32 divided by 8 is 4. 48 divided by 8 is 6. And then this is another situation where 4 and 6 are both even, so we can divide these by 2. And that gives us 2 over 3. And those numbers, they're both prime numbers, so those are going to be the simplified. And from here you can see why 16 goes into it, because 8 and 2, you multiply those together, you get to 16. So we could have divided both of these by 16 and done it in one step. So there's multiple ways to reduce these problems, and it's all based off of, well, what's the first number that comes to your head? If the first number that comes to your head is 4, then divide it by 4. If it's 2, then divide it by 2. But you want to be able to keep dividing it until you can't anymore. Are there any questions on either of these two examples? Are you the only one that checks your fractions using decimals? That is a good way to check, because if you put the fraction in it, like if you have a calculator and you type in 32 divided by 48 and then type in 2 divided by 3, you should get the same decimal form. I don't normally check this way because it's hard for me to remember how many, especially if it's a number with decimals that go on forever. With my calculator, I don't remember. I only see one answer at a time, so I can't really compare to see if they're the same. But that is a way to check your answer. Another question that I haven't heard anybody say or ask is, what if you can't think of a number to divide in? Or what if you're not sure? And so that's where you just have to do trial and error, basically guessing and checking. And if you're like, I don't know what number goes into this, well, let me try guessing. Start with 2 and 3 and then go from there. That's exactly what I do. I start with the small numbers and then I go from there. And this actually kind of goes into the mental math discussion, because there are shortcuts. Like if the number is an even number, it ends in 2, 4, 6, or 8, or 0, you can divide it by 2. If the number ends in 0 or 5, you can divide it by 5. If the numbers add up to 9, none of these add up to 9. Let me see. No, those don't add up to 9. I'm looking to see if any example. No, none of these do. But if your digits, like let's take the number 32 here. If you do 3 plus 2, that gives you 6. But if it had added up to 9, that means you can divide the number by 9. So tricks like that, they're called divisibility tricks. And they kind of allow you to say, check, oh, does this number go into it? And there's rules for 4, for 8, for 3, but those I don't remember. But you can always look it up. And then you can say, oh, this number divides into this. And it's part of the mental math tricks that some people do, is they memorize these rules. And then they know, oh, okay, I can divide this by 4 because it fits the rule. But starting with 2 and 3 is pretty good. And if you're wondering, well, I can't find anything, when do you stop checking numbers? You take the square root. So on your calculator, there's generally a square root button. So if you take the square root of 32 on your calculator, you're going to get a decimal, 5.65, whatever. Look at the whole number part. It's 5. So if I'm trying to see what numbers divide into 32, if you start with 2, check 2, 3, 4, and 5, and then if you have not found one from there, then you just stop, because there's not going to be anything that divides into it. That's also a good way to see if a number is prime. So while 32, 8 divides into 32, but if you're starting with 2, you would have checked 2 first, and that goes into it. So that's a nice little trick as well to kind of know when to stop checking numbers. Any other questions? One thing to kind of add on to like knowing if you can divide numbers by, try to put these numbers in terms of things you know. Like I play a lot of card games, and there are 52 cards in a deck. There's 13 of in each suit. And so I know 13 times 1 times 2 times 3 and times 4 because I know a deck of cards. I work with deck of cards. You can, if you know like clocks really well, you can do your times tables for 12, you know, so try to put things, or like 15, 30, 45, 60, your multiples of 15 because of the divisions of an hour. So if you try to put these numbers in terms of things you know, it can kind of help you. Okay, so this one we're going to do both methods because it's larger numbers. So we'll do the repeated division method, and then we'll do the prime factorization method. So I just wanted to revisit it with the larger numbers here. So repeated division method, let's actually do prime factorization first. Let's do repeated division. I can't decide which one I want to do first. Okay, so when you've got large numbers like this, the easiest thing is like to look at it and be like, oh, these I can divide these by 2, because 110 ends in a 0. I can divide that by 2, and 106 can be divided by 2. So with larger numbers, when you don't really know your times tables, you don't necessarily look at that and be like, what number can I divide into these? It's not obvious. So just start with 2. So if I can get the right color, we're going to divide the top and the bottom by 2. Because if you try to find something larger, you might be spending a lot of time, and it may not be, you know, worth it. So 110 divided by 2, you might want to pull out your calculator unless you happen to know it. This is 55. Now 176 by 2, that one I don't know, so I am going to pull out my calculator for that. Okay, 88. So now we have 55 over 88, and now we want to look at what else can I divide in? Is there something else that I can divide into this? I look at 55 and I'm like, okay, there's a 5. And we've got Tanya and Christy both saying 11. That's great. So if you have repeated numbers, 55, 88, 77, those are all divisible by 11. So we can divide these both by 11. So I'm going to put that in. And then 55 divided by 11 is 5. 88 divided by 11 is 8. And then 5 and 8 don't have anything in common. I can't divide a number out of both of those. So that is simple, or simplified, reduced. Now, looking at the original problem, I don't think I would have known immediately that 11 goes into it. You know, I looked at 110 and I said, oh yeah, 11 goes into that. But would I have been able to say that 11 goes into 176? No. I would not have been able to do that. So I would have started with 2 in this case and then said, okay, now what? Now where do I go from there? So now let's do this with prime factorization. And the thing about the prime factorization is we kind of know now what numbers go into it, so it's sort of like cheating. But I would have said, okay, 110 is 11 times 10. You know, I wouldn't have thought 2 times 55. I would have said, oh, this is a number times 10. And then 11 is prime. And then I would have split 10 up as 2 times 5. And then 176, I'd look at that number and I'm like, well, I know 2 goes into it. Like, that's as much as I know. And so I would have done 176 divided by 2. And that's where we got 88. And then 88, I would have said, oh, that's 8 times 11. And then, okay, 8, we've got 2 times 4. And then 4 is 2 times 2. So that would get me all the way to the end. And then instead of writing 110 over 76, I would have 11 times 2 times 5. And then 176 would be 2 times 2 times 2 times 2 times 11. And then I would just start canceling things out. The 2's and then the 11's. And then I'm left with a 5 on top, and then the 2 times 2 times 2 gives me 8. So we get the same answer with the prime factorization. So in this case, you know, it's a little more work to do prime factorization. I might have been inclined to start with the prime factorization in this case just because 176 is pretty large, and I would assume lots of numbers go into it. And you know, I would have looked at this and thought, okay, this is not going to take me 2 steps. It will take me more steps. Now we got lucky. The repeated division was only 2 steps, but sometimes you can do the repeated division and it takes 5 or 6 steps. And that's where it's like, oh, maybe I should have just done prime factorization. So I've got one more example here, another one with 3-digit numbers, and I'm actually going to do prime factorization first here, and then we'll do the repeated division method, just for a change. So we've got 210 over 119. So first I'll start with 210. So I know because it's got the 0, it's multiplied by 10, and that would be 21 times 10. And then 10 is 2 times 5, and those are prime numbers. And then 21 is 3 times 7, and those are prime numbers. So then I would look at 119, and I look at that and I'm like, well, 2 doesn't go into it because it ends in a 9. So I'm going to just literally pull out my calculator. So first I want to know, what do I need to check? So if you do the square root of 119, it gives me 10.9 and a whole bunch of decimals. So I'm only going to check the numbers up through 10. So I know that 2 doesn't go into it, so I'm going to try 119 divided by 3. And if you get a decimal, then it doesn't divide. So then I got a decimal, so then I'll try divided by 4. And that gave me a decimal. Divide by 5, that gave me a decimal. Divide by 6, I got a decimal, and I see I was beat to it. Finally, 7. This is not something that I would have figured out easily. So it's a 7, and then my calculator gave me 17. So 7 is prime, and actually 17 is prime as well. So now I'm going to rewrite this. So we started with 210 over 119. So 210 is 2 times 5 times 3 times 7. 119 is 7 times 17. So the only thing they have in common is 7. There's nothing else in common there. So then I'm going to multiply 2 times 5 is 10, times 3 is 30, and then a 17 here, and that is going to be the reduced form because we basically canceled everything out. Now let's say we were doing the repeated division method. So if you were doing the repeated division method, you have to think of what numbers go into both 210 and 119. So you would have to say, okay, let me start at 2. 2 goes into 210, but not 119. So you would have to, like, on your calculator, try it in both numbers. Then you would be like, okay, 3, that didn't work. Let me try 3, 210 divided by 3. That works. Does 119 divide by 3? No. So then you need to keep going. 210 divided by 4. Nope. Okay, let me try 210 divided by 5. That works. Does 5 go into 119? No. You have to actually, with larger numbers like this, you have to sit there on your calculator and you have to, if you can't think of a number that goes into it, like 119, if you can't think of anything off the top of your head, then you have to sit there and try every single number, and you have to try it in both of them. So, you know, like I tried 5 in both. Okay, so let me try 6. 210 divided by 6? Yes, but does 6 go into 119? No. So then you have to do 210 divided by 7. Okay, does 7 go into 119? Yes. So you have to try multiple times, and it takes a while. And so, Christy, you thought, oh, let me try 21 because 21 goes in 210, but, you know, so, and if you try 3, you know, does it go into the other numbers? So you do this in one step, then you have to go on your calculator, 210 divided by 7, which is 30, 119 divided by 7, which is 17. So the repeated division does it in one step here, but you have to sit there on your calculator and figure out what numbers go into both 210 and 119, or on scratch paper trying to write this all out. And it's very time consuming. Now, in this case, the prime factorization method was better because I didn't really have to do any guessing and checking on 210. That was pretty easy for me to split down. I only needed to do guessing and checking on 119. So it saved me some time. Instead of checking both numbers, I only really needed to check one of the numbers. And then once I've got that reduced, I just cancel things out. So this is one situation where I think knowing the prime factorization method is better because it's less guess and check. You're not sitting there on your calculator as much. If you have something like this one where they're both even numbers, I would just do the division method. If you can divide them both by 2, just keep doing that until you can't get any more. As soon as I end up with a number that's odd, and they're pretty big numbers like this, that's when I usually do prime factorization because it's usually harder to find a number in common. But of course, both methods work. It's just a matter of how much time do you want to spend on your calculator trying to figure this out. Are there any questions? Okay, I'm glad that that makes more sense. I'm going to show my camera again. So I'm going to show how I do. So this is the calculator that I have. This is the TI-30X, and apparently I hit a button. But this is what I have. So to do the square root, if you're wondering on here, so like we're doing the square root of 119. So I have to hit the second button. And then, okay, you gotta zoom in enough and hope it, right above the x squared is the square root. So you hit second and then you hit the x squared and then the square root symbol shows up. And then you type in the number. So like if I want to find the square root of 119, and then you hit enter, if I can find it. And then, so that's 10.9. So that's where I knew I only needed to check the numbers up through 10. So knowing your calculator and how to use your calculator is very important because it will save you a lot of time. This calculator also does fractions and will reduce them. So if you're wondering how to reduce fractions on this calculator, so gotta let it focus again. So you see this A, B, C button, and then there's some stuff above it. And then we have this button that says PRB, and above it says FD. So the yellow above the PRB button converts things from fractions to decimal and vice versa. This is how you write fractions. So if I wanted to do 100 or 210 over 119, I first put in 210, and then you hit this ABC button, and then you put in 119, and then, come on, focus. Doesn't want to focus. But then you hit enter. And so it gives it to you as a mixed number, which we don't want. Oh man, this really does want to focus. Kind of good. It's really hard for me to aim here. And now it's getting reflection. Well, it gives it to you as a mixed number. We don't want a mixed number, but we can convert it to an improper fraction. So what you do is you hit the second button here. There we go. And then you hit the ABC button, and then you hit enter, and then it converts it to its regular form, 30 over 17. So I recommend use your calculator for fractions on the quiz, because I am more interested in us doing the algebra. Understanding fractions is important because there's algebra we'll be doing later that uses these same concepts, but this will save you a lot of time. So if you have this calculator, which a lot of people usually have, that's how you do fractions. So definitely make use of that on the quizzes. But I do recommend, like on the homework, do it by hand so you can learn the rules and everything like that. So any questions? Anything else? How do you turn it off? Hit second, and then other way, on, and then it will turn it off. So that's the second goes with anything in yellow. So if you hit the second first, if you want the thing in yellow, and then you can use the yellow portion of it. So yeah, a lot of people never know how to use it. Yeah, all these calculators. Honestly, like when I was learning how to use this calculator, I just literally typed in the name of the calculator into Google and wrote manual to figure out how to use it. And I've also got a graphing calculator around here that I use, and this thing has so many more buttons, and I often have to look in the manual on how to use this thing too, because I don't remember. But in the PowerPoint that I am going to share out tomorrow, and actually let me open up a browser and then I'll share this with you guys. Let me share my browser again. So in the PowerPoint, I'm going to email out with like the scientific calculator and everything like that. There is the link to the scientific calculator in the browser. It's desmos.com/scientific. So this is what we want. And so this is an online calculator, but this also does fractions. So if we wanted to do 210, you hit your fraction button. Oh, that gives you a mixed number. Hit the fraction button first, then hit 210 over 119. It defaults to giving it in your decimal form, but if you hit this button here, it will give you the reduced form. And then there's also the square root button here. So this is an option as well. I like this better than my physical calculator just because I can actually see what I'm entering in and making sure that I'm doing it correctly. So you might want to bookmark this website and use this as well, especially if you don't have a physical calculator, because it does basically everything that you need. It's got the square root symbol. It has a pi button. It even has absolute value. It has exponents. So it has some extra stuff here It can do variables. I've never messed around with any of that. This stuff over here is stuff that you need for college algebra, but not in our class. So we can just stay in the main part. But I also like this one because if I hit enter, I can still see my answer. So on my other calculator, once it's gone, it's gone. I don't remember what I wrote in it. So this is a good. Oh, I didn't even know that I can make it bigger. I've never done the options, but this is in the first PowerPoint that I'm going to email out with the links. So this is a good resource. Great question. When we submit our assignments, how much of a process do we need to show? If it's like a one-step problem, like if you're asked to do the absolute value of something and you can do that in your head in one step, you don't have to show any work, just give the answer. If it's a multi-step problem, like with order of operation problems, you're going to want to show every step. Just so that we can give you partial credit. And then that also helps you double check to see if you've made any mistakes. So if you can do it in one step, you don't even really have to write anything down. But if it takes more than one step, write everything down so that way you have it on paper and you have something to submit. So if it's like a question, like sometimes there are questions where you just have to pick a choice, then you don't really write anything down because you're just picking a selection. So it depends on how much work you have to do, but the general rule, if it's more than one step, write it down. Otherwise, it's fine. You don't need to write anything. Any other questions? All right. So it's after 9 o'clock my time. We'll call this good. Thank you guys for showing up, being interactive. 4 a.m. Oh my goodness. 4 a.m. Oh, you're going to work at 4 a.m. Not that it's 4 a.m. there. Yeah, time to go to bed. Yeah, anybody who did work by today for Connect Math, I'm going to give extra credit for because of our Connect Math issues. But yeah, I'm going to be doing this every week. I have previous terms, like because I record all of these in Blackboard on that videos link, you can see all of my old ones. So I have videos on pretty much everything that you're learning in the class. So you can watch it if you're live. Yeah, I've got and these are also on YouTube. It's the same thing. So you can subscribe to my YouTube. You can Google my YouTube, search on my YouTube for certain topics. Because I also have like my college algebra ones there, so you can see I've got multiple versions of videos, and so, but there's nothing like being live and being able to ask questions at the same time. So, and if there's a specific topic that you're like, I really need you to cover, let me know, and I can make room for it. So I can definitely do that. So, all right, well, I'm going to call this thing done. All you have to do is close your browser to exit out of it, and I will see you guys at the next one next Monday, unless I reschedule, but I think this time seems to be working out pretty well, so it will be next Monday. So, all right, everybody, take care, good night, have fun, see you at the next one.